Okay, so we're going to work through the 12-2 notes on chords and arcs. A chord, by definition, is a segment whose endpoints are on a circle. So you can see in the diagram here, segment PQ is a chord, and segment PQ, we say that intercepts arc PQ. So arc PQ is going from P to Q on the minor arc. So you can kind of see that here. So that's, if we say what is the intercepted arc by the chord, you would say arc PQ. All right, within a circle or in congruent circles, there are three things, and I kind of set them up. I drew these lines in which are radii, which may help. You can prove this with different, actually, triangle congruence theorems. I'm just not getting into that on the video. So congruent central angles have congruent chords. So that's what I'm telling you is right here. If I say this angle right here is congruent to this angle right here, then you can conclude that chord AB is congruent to chord CD. Okay. The converse of that, if I tell you the chords are equal, AB is congruent to CD, you can say that the arcs are equal. And if the arcs are equal, then the central angles are equal, which is something we should already know. So these are all kind of saying the same thing. If you have congruent chords, the central angles will be congruent, and the arcs they cut off will be congruent as well. Within a circle or in congruent circles, chords equidistant from the center are congruent. So we have the center of the circle. We've already defined distance earlier this year. From a point to a line is the perpendicular distance. So XA represents the distance of EF from point X. And we're saying in part 1 that XA is congruent to XB. They're equidistant from the center of the circle, which is X. And once you know that these are equal, you can conclude the chords are also equal. And again, on a different day in class, we can work through some of the proof. If you draw some radii in, you can prove it with some congruent triangles. We also have the opposite of that, where if I say the chords are equal, then you can conclude the distance from the center is equal. Please remember, it doesn't mean any segment from the center to the chord. It's that perpendicular segment that represents the distance. Okay. Down here, a diameter that is perpendicular to a chord bisects the chord. Notice it says diameter. It isn't just any line that does it that's perpendicular to the chord. So this is a diameter. It is perpendicular to chord DB, and therefore it bisects chord DB into DE and EB. You can see that here. In number 2, a diameter that bisects a chord that is not another diameter is perpendicular to the chord. So in this one, I kind of reversed this information I told you. I said, listen, DE is equal to EB, and then you can say, oh, well, I see AC is a diameter, and that must mean it's perpendicular. And if AC is the perpendicular bisector of DB, so we're told, listen, here's AC, that's a diameter, and it is perpendicular to DB, and it bisects DB, so it's perpendicular and it splits it into equal parts. Our conclusion is that AC goes through the center of the circle. It's a diameter. So looking at this circle, circle L, okay, I'm going to tell you that YM is congruent to ZN, and then you're going to look for what you can conclude. Okay, so if you draw that diagram, you may need to push pause, because what I'd like you to do is draw that diagram, and in your small groups or just on your own, try to answer these 3 questions. I'm going to come back and tell you the answers, but I want you to think about them and see what you can figure out, and then push play again when you're ready for the answer. So push pause now. Okay, so if YM is congruent to ZN, that means there's a congruent chords. If they're congruent chords, that means they cut off congruent arcs. So YM, arc YM, is congruent to arc NZ because they told us the chords were congruent. If segment YM and segment ZN are congruent chords, explain why you cannot conclude that LV equals LC. And I know what you're thinking. These are congruent chords, so their distance from the center is equal. Well, you can see LV and LC, they don't have that perpendicular part I talked about. So they're just a segment connecting the center to the chord, but since I don't know they're perpendicular, I don't know they represent that distance, so I don't know that LV equals LC. So be really careful of what the diagram is showing you. All right, down here I kind of drew a separate circle since I knew we couldn't see the top. Suppose that YM is 12 and its distance from point L, which is the center, is 5 inches. So you can see I drew that here and labeled it. And since this is perpendicular from the center, it is dividing the chord in half. So these segments are 6 and 6. Find the radius of circle L. Well, I drew the radius here in green. Now you could have drawn that anywhere. I chose to draw it here because that helped me form a right triangle. And once I've got the right triangle, I can use Pythagorean theorem, which you can see I used here, and get your answer. All right, over here, again, we have 3 circles, and I'm just going to ask you to please push pause, try to work through these the best you can, see what you can figure out, and then push play again to check your answers and see how you did. All right, over here, that red dot is marking the center. That means this is a diameter. I can see that it's perpendicular to the chord because there's a right angle. That means it's splitting this chord into 2 equal segments. I see a right triangle here, so I'm going to use Pythagorean theorem to find y. Y is 12. And then again, because this is a diameter and it's perpendicular to the chord, I know it splits it in half. So if y is 12, x is also 12. In the next one, I use this 30, 60, 90 triangle here. Hypotenuse is 6. This angle is 30. So across from the 30 is half of that, 3. And across from the 60 is 3 root 3. Down here, they are equidistant from the center. That's how I mark that. So that this is 8 and it splits the chord into equal parts. So if this is 8, then x is 8. So that's part 1. Then since they're equidistant from the center, the whole chord is equal to that whole chord. Well, this whole chord is 8 plus 8, that's 16. And since this is equidistant from the same center, it's 16. Okay, again, give this one a try, see what you can figure out, and then we will come back to it. Okay, in this one, again, here's the diameter perpendicular to the chord, so it's splitting the chord in half. That's how I knew that x was 5. EF is 10. It tells me that. And since I know that this is 5 and this is 5, I know that chord AB is also 10. So EF and AB are equal. That means the arcs are equal. So this whole thing is 86. Then arc AB is 86, okay? And if this diameter makes the chord split in half, it also makes the arc split in half. So what I did is, I know here is 86. To get y, I took 86 divided by 2. Right, down at the bottom, you can see the diagram I drew. It's kind of similar to what we did before. The length of a chord that is a distance 5 from the center, so there's the 5. That would be a right angle. I just didn't draw that in. With radius 8. So I drew a radius of the circle. You can draw it anywhere, but again, I chose from here to the end of the chord because I wanted to make that right triangle. And then I used Pythagorean theorem here, and I got that this piece here is the square root of 39, but remember I want the length of the whole chord, so I'm going to double that, and that's how I got 2 root 39. All right, here is, I believe, the last set of problems. So again, I want you to push pause. You can work with a partner, work with a couple people, try to get through as many as you can, and then you can come back and check with me. The one thing I do want to add is that this should be arc CD. Okay, push pause. All right, for this one, RT. Okay, actually that should not be... That should be 30. I have to fix that one. 30. Okay, so RT is 30 because MT is 15 and RT is twice that, so it's 30. For OM, again, I used the Pythagorean theorem. 17 was the hypotenuse, 15 is the leg, Pythagorean theorem. You'll get that OM equals 8. over here for arc ACB, well, the whole circle is 360, and I subtract the 220 over here, and I get that arc ACB is 140. For angle AOC, well, this is perpendicular to the chord. So since it is perpendicular to the chord that intercepts that arc, it's splitting the arc in half. It splits the chord in half, and it splits the arc in half. So I did the ACB 140, divided it by 2, and got 70. And remember, central angle equals the intercepted arc. So that's how I got 70. In the last one, I have two chords. I can see they are equidistant from the center. Since they're equidistant from the center, the chords are equal. And since the chords are equal, the arcs they intercept are equal, which is how I got that arc CD, the measure of arc CD, is 80 degrees. All right, and that is going to conclude. You should have those notes all complete, and you're going to check Canvas to see the homework that